12.2, simplifying radical expressions. How can you simplify expressions containing rational exponents, which means fractions, or radicals involving the nth root, which means square roots or cube roots or something like that? Alright, I'm going to start and go over page 659, which has the rules on it for you. This is an important page. You might want to take a few notes on your own because you have to know these rules in order to work the problems. They're the same rules you probably learned in Algebra 1. We're just going to look at it a little more in detail. So first of all, the product of powers property. That means if I take a variable or a number and I multiply it by the same variable with a different number, or it could be the same, when I multiply, I add my exponents. So when you multiply and you're using powers, you're using exponents, you add the exponents. So if these were both fractions, what would I have to add those fractions? Common denominator. Okay? So that's a product of powers. The second one, quotient of powers. Now remember, quotient means the answer to a division problem. So if I have, let's say a to the 2/3 divided by a to the 4/7, when I divide with fractions or with exponents, I subtract. Okay, so when you multiply, you add. When you divide, you subtract. Here again, if they're fractions, I have to get common denominators. Power of a power, or power to a power. That means if I have a to the 2nd to the 7th, that is called a power to a power, or a power of a power. They're next to each other. On this, you would multiply the powers. Multiply the powers. Power of a product property means if I have variables or numbers or whatever inside the parentheses with a power on the outside, it means that that exponent, that power, goes with everything inside the parentheses separate. So really this means a to the 7th, b to the 7th, c to the 7th. That power goes with everything. It's distributed all the way through the parentheses. The power of a quotient property. When I have a quotient inside the parentheses with a power outside, same thing. That means I distribute that power, that exponent, to everything in the parentheses. So this would be a to the 5th divided by b to the 5th, c to the 5th. That exponent goes with everything, every variable variable, every number inside the parentheses. Any questions? Anybody? Okay, we're going to work all the your turn problems starting on page 660. I'll show you how this works. All right, your turn number 3. Now, I have multiplication inside the parentheses, and then I have it raised to a power here. So I can do this several ways. You're always told to do parentheses first. So let's do what's inside the parentheses first. This is multiplication. So what do we do with these two exponents right here on multiplication? Add them. So I have 2/3 plus 4/3, which equals what? 6/3, which is equal to 2. So actually inside my parentheses, I have 12 squared. And I still have to the 3/2 because I haven't done anything with that 3/2 yet. Now I have a power to a power. So a power to a power, I multiply. So really that's 2/1 times 3/2, which is just 3. So actually this says 12 cubed. And then you just put that in your calculator, 12 cubed, and you get 1,728. Now, can you check it by putting all of this in your calculator? Yes, you can on this particular one. Any questions on how we got that? Anybody? Okay, let's go to example 4. Your turn number 4. All right, I have all this in parentheses squared, which really means 6 squared x to the 1/3 squared over x to the 5/3 y. So I just put the 2, that exponent with the 6 and with the x to the 1/3. So let's start simplifying this. What is 6 squared? 36. What is x to the 1/3 squared? 2/3. That's right. Over x to the 5/3 y. I have x's both in the numerator and the denominator, and both of them have exponents on it. What do I do with my exponents when I divide? Subtract. So I have to just subtract 5/3 minus 2/3. 5/3 minus 2/3, which equals 3/3, which equals 1. So it's x to the first power. Now, am I going to put that, I have 36 in my numerator, am I going to put that x to the first power in the numerator or in the denominator? I'm going to put it in the denominator. Why do you think that is?
Because you subtracted from it.
I subtracted from it, and why did I subtract from it?
Because it's division.
Okay, because it's division, but why did I say it's what?
Bigger.
Bigger. Where the exponent is bigger, 5/3 was bigger than 2/3, and so my answer is going to go in the denominator. Okay, when that exponent is bigger, that's where you put your answer.
So if it was bigger in the numerator, would we put it in
Yes. If this had been 5/3 and this had been 2/3, then you would put the x up in the in the numerator.
So it doesn't matter at all which one. You just pick the bigger one.
Well, I would, otherwise you're going to get a negative, and then if you did it the other way, you would get...
Okay, so if you did it the other way, you would just have put it on, you've gotten a negative and put it on top. So you just put it with the...
Right.
Okay.
So if you got a negative on top, you're still going to have to move it to the bottom and make it positive.
Yeah, exactly.
So it'll be the same. You're right. Any other questions? Okay. Let's go to your turn number 5. It is on page
661.
661, right there in the middle. Alright, so I have radicals on this problem, and so let's get rid of those and look at what the exponents tell us. So right here I have x to the 3rd, and it's a square root, so that would be x to the 3/2, just like we did on 12.1. And this one would be x to the 2/3. So my variables are the same, and it's division, and so what do I do with the exponents now? Subtract them. So I'm going to take the largest one, which is in the numerator, 3/2, and subtract the smaller one. To subtract fractions, I have to have a common denominator, which will be 6. 2 will go into 6 3 times, that will be 9/6. And 3 will go into 6 2 times, which will be 4. So that will be 5/6.
Yes.
Numerator or denominator?
Numerator.
Numerator. X to the 5/6. Any questions? Number 6. 16, the 6th root of 16 cubed. How would I write that?
16 is half.
16 to the 1/2, which is actually 16 to the 3/6, but he went ahead and reduced it, 16 to the 1/2, times 4 to the 6/4, which is 3/2, times 8 to the 2/3. Now, what the book wants you to do is they want you to get all of these bases the same. I'm not going to have you do that. We're going to do it the easiest way. So what is 16 to the 1/2 power? Or what does 16 to the 1/2 actually mean?
16 squared.
Square root of 16. So what's the square root of 16?
4.
Or if you wanted to put it in 16 to the 1/2, that's fine. So that's 4. What is 4 to the 3/2? 8. What is 8 to the 2/3? 4. So 4 times 8 times 4? 128. That's your answer right there. Any questions? Okay, let's go to page 663. We're going to do problems your turn 8 and 9. The cube root of 216x to the 12th y to the 15th really means 216x to the 12th y to the 15th to the 1/3. I just put everything underneath the radical, the whole radicand to the first power, and then that's the cube root of it. So now we'll separate it out 260